Okay, you're welcome, everybody. I'm in my office at SETU this morning, and I'm going to work through the another one of the electrical questions in your booklet. Okay, we're on to question E3, and I need to share visualizer with there. And from the visualizer, you can see the circuit in question E3. And as we said before, the questions are pretty well all the same. So we start with working out what the total resistance is of the circuit. Now, if you look at the circuit, we have a pair of resistors in parallel. Current comes in, splits, goes along either arm, and then recombines. The full current then goes here, splits along the two arms there, and then recombines. Okay, so we can easily work out. So we see that the 100 is in parallel with the 50, and the 200 is in parallel with the other 200 ohm resistor. So we work out each of those in turn. 1 over R sort of 100 parallel 50 equals 1 over R1 plus 1 over R2 equals 1 over 100 plus 1 over 50. You can do this by fractions, or you can do it by just using your calculator. You'll end up with a 3 over 100 if you display it in fraction form, or that's equal to 0.03. Now, always remember that's 1 over R. Therefore, the value of the resistance of the 100 in parallel with the 50 is 100 over 3, or 1 over 0.03. And that equals 33.3 recurring ohms. Right, so we know the resistance, the effective resistance of that connector there. I'll just move that out of the way. Now we have the 200 in parallel with the 200. And I think you might remember me telling you that if you have two equal resistors in parallel, then the total resistance is just equal to half either resistor. So the answer we're going to get is 100 ohms. So anyway, just to go work through this, 1 over 200 plus 1 over 200 equals 2 over 200, which equals 1 over 100. And therefore, R 200 in parallel with 200 equals 100 ohms. So now we can redraw our circuit diagram. We have 33 and a third ohm resistor, a 100 ohm resistor, and then of course the 80 ohm resistor up here. So 33.3, 100 and 80. They're in series, so our total now just is R1 plus R2 plus R3. Add them all up. 33.3 plus 100 plus 80, and you'll get 213.3 ohms as our answer. And that's part one done, or part A. Part B, always the same. What is the current at the battery? Apply Ohm's law to the whole circuit. VT equals I RT, and the VT is the, oh, if I just move that down again, VT is the 15 volts that we had in the original circuit. So that means 15 equals I times 213.3, divide by 213.3, divide by 213.3. And with that calculation, you get 0.0703 amps, or 70.3 milliamps as a circuit. Again, quite a straightforward part to the question. Moving on, now we want to know what's the potential difference across each resistor. So we start off with the 33. So the potential difference across the 33 ohm resistor, 33.3 ohms, which equals, just if we go back up here, that's the potential difference across that resistor and the potential difference across that resistor. So that's equal to V100 and equals V50. So we just apply Ohm's law to it. It's I times R. The current flowing through on this circuit is 0.0703. And we multiply that by the value of the resistance going through. Now, of course, it's not going through that actual resistance. It's going through these two. But this is an equivalent resistance. Potential difference across there and there will be the same as the PD there and the PD there. So multiply that by 33.3 and we get for that one 2.34 volts. Right. Now the next one we come to is the 100. And of course the V100, going back to the original, is the potential difference across that resistor and that resistor, which is V200 in each case, equals IR equals 0.0703 multiplied by 100, which equals 7.03 volts. And finally, we have the 80 ohm resistor, V80 equals IR 0.0703 times 80. And when you multiply that by 80, you get 5.62 volts. Now, if we add these up, 4 and 3 is 7 and 2 is 9. 6 and 0 and 3 is 9. 5 and 7 is 12 and 2 is 14. So we get 14.99 volts when we add them all together, approximately 15. So within rounding error, we're on the right track. Part D. And now we know the potential difference across every resistor in the circuit. The potential at points A, B, C, D, and E. So again, moving to the top circuit, we can compare. A is here, B is here, C is here, as is D. C and D are going to be at the same potential because they're joined by a simple wire. E is over here, and F is here. And just to remind you, we've worked out that the potential drop across each resistor, the 33 minus 2.34. So this is minus 2.34 volts. This is minus 7.03 volts. And this one is minus 5.62. What I mean by that is that the energy of the electricity coming out of the 15-volt battery is going to be 15 here, and then it loses 2.34 going through that resistor. Then it loses 7.03 volts going through that one, and finally it loses 5.62 volts going through that one. So what are the potentials? Well, we already know VF is 0 volts. VA and VB are both the same, and they must be equal to whatever the power supply voltage is. So VA and VB both equal 15 volts. Then the current loses energy going through that first resistor. So the amount of energy it loses is 2.34 volts. So VC equals V at D, and that equals the 15 that it has at point B minus 2.34. And a bit of maths, 12.66 volts at that point. So 12.66 volts in there. Now VE equals the value of the potential here minus what it loses going through here. So that's 12.66 minus 7.03. And I get 5.63 volts. And that 5.63 volts is what it loses going through the last resistor. So that would seem to have worked out okay. Okay, so that's the first 4 parts of the question. On to part E. And in part E, what's the current flowing in the 200 ohm and 100 ohm resistors? Okay, so what we want to know is what current flows here and what current flows for either. Now, for this one, it's kind of, you might be getting the sense now of how these work. In this one, it's whatever current is in here, because these two resistors are equal, half will go that way and half will go that way. But in general, you just apply Ohm's law. Apply Ohm's law to each resistor. We know the potential difference across that resistor. We know the size of the resistor, so we can work out the current. Ditto from over here. We know the potential difference across that resistor. We know the size of the resistor, so we can work out I. And remember, we've worked out all these potential differences. The potential difference across each resistor is calculated down here. So in part E, first of all, we know, we'll look at the 200 ohm resistor. Let's get this lined up for you. So the 200 ohm resistor, well, we know that V200, from what we've calculated already, is 7.03 volts. And we know the resistance is going to be 200 ohms. Therefore, I equals what? Well, apply Ohm's law. 200 ohm resistor. V200 equals I200 times R200. Or what we normally do, if I divide by R200 there, R goes down here. V200 over R200 equals I200. That's going to equal 7.03 divided by 200. Get my trusty calculator out. Or actually, even better, just look at the answer and you get 0.035 amps. Now for the second one, it's the 100 ohm resistor. Again, if I look through my previous answers, the potential difference across the 100 ohm resistor, V100 equals, let me just check here, 2.34 volts. And R100 equals 100. Now, we already have the equation for working out R here. We're just going to, working out I here. We just use Ohm's law. So I100 equals V100 over R100. It's always V over R. That equals 2.34 divided by 100, which equals 0.0234 amps. Okay, and that's us finished with question E3. As usual, I just ask you now to have a go at question E4, and you can watch the video later then to see how that, the proper solution to it. I'll stop sharing for now, and I'll stop the recording.